All right, for the Ready, Set, Go for lesson 2.1, the ready portion is all about patterns and being able to recognize what is happening with the pattern. For number 1, we have positive, negative, positive, negative. So what we know is that we're going to be jumping by a negative amount each step of the way. And because it's jumping so much, we can tell that it's going to be multiplying each step. And if we do this, we'll end up getting multiplication. So we'll be multiplying by a -5. So if you continue this on, you end up with 2,500 and negative 12,500. Because we are multiplying, we know that this is a geometric sequence. For number 3, if you subtract, you'll see not a very even subtraction. The tricky part here is figuring out what multiplies each step of the way. We know it's getting smaller, so we know it's going to be a decimal or a fraction, but if we end up multiplying each step by 3/4, you would end up getting the next step. So multiplying 27 by 3/4, you would get 20.25. And then simplify, or putting it out as a decimal here. Actually, let me do it as a fraction. So you would get 81/4 and then 243/16. So you're just multiplying 3/4 each step of the way. And again, because we're multiplying, we know that this is going to be a geometric sequence. I want to pick one different one because I don't want to just keep going over geometric. Let's go through number 6. So 1, 11, 111, 1,111. We know that just based on what we see, the next one is going to be 11,111 and then 111,111. So that's a weird thing to write, just a bunch of ones over and over again. And the reason I know that is because I'm just adding on another place value of a 1. Because of that, we would say that this is neither arithmetic nor geometric. So try to play around with those. I would encourage you to, for number 7, I will tell you that it is geometric. So try to find something that you can multiply. It's getting more negative, so it's going to be getting smaller. Just try to work through what some possible answers might be. You might want to take -5.4 and divide it by -3.6 and see what you get. Okay. So that was one that I definitely want to make sure that you are aware of. The predictable sequence of at least 4 numbers that is not arithmetic or geometric. So here's one that you could do. 1, 101, 1,001, 10,001. Okay. That's what this is looking for. This is not arithmetic, nor is it geometric, but it's still a sequence that I can predict. Please don't use this example, but try to find one of your own that you could use. For the set portion, numbers 10, 11, 10 through 15. I've got the first 4 up there. The last 2 aren't on the screen. So I'll go through a couple of these. We want to talk about discrete and continuous. Discrete is individual moments in time. Continuous is continuing on. So for number 10, the hair on your head growing. Your hair does not know that, oh, it's the first of the month, let me grow a little bit. It's not like, hey, the first of every month, your hair grows a ½ inch. Your hair is constantly growing or continuously growing. We just choose to measure it at certain points in time for those who do. So this would be considered a continuous situation. For every ton of paper that's recycled, 17 trees are saved. Every ton of paper, 17 trees are saved. So what we're looking at here is, if I save less than a ton of paper, do I save less trees? Or do I have to save 1 ton of paper to save 17 trees? Okay. So in this case, I would consider this a continuous relationship. Because if I save 500 pounds of paper, recycle that, I'm still saving trees. I'm just not saving 17. Number 12, 3.24 billion gallons of water flow over Niagara Falls daily. I would consider this also a continuous representation because it is always happening. It's flowing, it's flowing, it's flowing, it's flowing. It's not like it just stops. And at the end of every day, 3.24 billion gallons of water dump out. Okay. For number 13, average person laughs 15 times per day. You're not constantly laughing, maybe, but good chance that it is happening at different points throughout a day. So we would be able to say that this is a discrete relationship. Okay. For the go portion, we're talking about unit rates. So if you have 4 pounds of apples, they're $2. What is the price for 1 pound of apples? So you know that we are trying to find the cost per pound. Okay. We're trying to find the cost of the apples for every pound. So we just plug in numbers. We know that it's $2 for 4 pounds. And when we divide it out, it is 50 cents per pound for the apples. Number 18, dozen eggs are $1.98. Same thing. We know that we know dollar, so the cost per dozen. Okay. What we're looking for, though, is we want cost per 1 egg. That looks like leg. So let me go here, 1 egg. So the cost was $1.98 for 12 eggs. And what is the cost for an individual egg? Well, that would be 17 cents per egg. Best Buy shoes, no longer into electronics. They're now selling shoes, had back to school special. The total for 4 pairs of shoes, $69.24. It's the average price for the shoes. So we know that it's $69.24 for 4 pairs of shoes. The cost for each individual pair, $17.31 per pair. For number 22, all the way through number 30. And again, I don't have them all up on the screen, but I'll do a few. We are just trying to isolate the x. So to do that, we'll use some inverse operations. So we'll divide both sides by 6, x equals 12. That's all that's doing. For number 23, again, isolate the x. So divide both sides by 4, x equals 50. Everything's great. For number 24, isolate the x. So divide both sides by 3. X equals what? 50 over 3? Leave it as a fraction. If you turn it into a decimal, great. Leave it as a fraction, great. Okay. The last one I'll do, number 26. 1/2 x equals 17.31. So instead of dividing by, well, now we've got a division problem. We've got 1 divided by 2. So the inverse of that would be multiplying by 2 over 1. Multiply by 2 over 1 on this side, and x should equal 34.62. Put a box around it, and you're done. The last part of this, number 31, that you don't see on the screen, some of these could be represented in the work that we did in 16 through 21. Number of the equation next to the story that it represents. So if you look and you see 6x equals 72, not sure. Maybe there's a representation there, maybe not. If you look at number 23, you have 4 pounds of apples at a certain cost each equals 200 pennies. Okay. So for example, number 16 and number 23 would have a whole lot in common. Take a look, see if you can make other pairs with that, and let me know if you have any questions at all. Hopefully this helped.